do you by chance know what the original speaker's topic was, Amir?
I don't, because unfortunately we didn't get to the point where we had an established agenda. So,
Well,
but she's going to cover a lot of the core principles that you probably will be covering today. So, yeah.
my goal for this session is not necessarily to dive too deep into like the core of the language, but to just kind of use some examples as like an axis to discuss some of the common language features that you kind of see crop up again and again. You know, there was only about 4 days to put this together, so what I ended up doing was kind of culling just some use cases or some examples of problems that we run into with Python I work with on a day-to-day basis. So just sort of highlight them as, you know, what does your slice of life, day-to-day Python programming look like?
Perfect. All right, so it's 2:03. I say we get the show on the road. Welcome everybody to our summer programming webinar series. This is our second or third installment of this summer programming series that we've had. And we're just going to keep it going traditionally. So we have our speaker here today, Jonathan Solis. He is a software engineer at Acquaint. You can correct me if I said that wrong, sorry. Based in Madison, Wisconsin. So Jonathan's going to go over a lot of the agenda and a lot of the other core principles that we're going to be covering today. But I just want to make sure everyone's aware we're going to have it as a 2-day event so that there's enough time for questions. And we want this to be a very interactive experience to everybody. So if you have any questions and you have any, you know, anything you want to clarify, please drop any questions you have in the chat or feel free to raise your hand. And then just make sure that if you're not talking, we remain muted. We just don't want any background noise or anything like that. We'd really appreciate it. At the end of it, we will send out a survey. Just provide us with your feedback. Tell us what your experience was like, how we could probably improve on a lot of things you want. And then we'll take it from there. So we're gonna go up until 4:30 p.m. today. And then we'll leave some room for any questions at the end of the day, and the same for tomorrow too. All right, so I have nothing else from my side. I'll just hand over everything to Jonathan and take it away.
Thank you, Amir. It's a pleasure to be here with you guys today. So this session I'm calling Bread and Butter Python Programming. A working programmer shares a few tips from the quote unquote real world. So today's agenda includes, first I'm just going to give you a little information about myself and also some disclaimers. We're going to do a quick audience poll. I would just like to know how much experience relatively you guys have with Python as a programming language. After we get a feel for that, we're going to do a brief overview of Python, sort of 10,000 foot point of view. Why do people love Python? Because people do love Python. It is a very popular programming language. After that, we're going to look at the PyCharm IDE overview. I believe that Umir forwarded you an email with a link to download the community edition version of PyCharm, which is free and awesome. I'm going to be using the community edition as well today for demonstration purposes, just so that we're kind of on the same page there. We'll have a moment to sort of make sure if anybody has any questions about either getting their setup correct or the IDE. We can stop and chat about that for a couple minutes. After we kind of have that established, I thought we could do some coding. I would like to start with a few, like just a couple of academic problems, or at least problems that you learn in college, namely Fizzbuzz, We're going to talk Fizzbuzz. Fizzbuzz, I think, is sort of like the easiest way to like get a flavor of what a language has to offer. And then we're just going to do a real simple iterative binary search in Python, just for the purpose of introducing those constructs. I'm missing a bullet point there, but after that, I'd just like to expound a little bit upon what I consider Python in the real world to be about, and just my experiences with that. Actually, I got a little bit rushed at the end. Python and AWS, we're going to save that guy for tomorrow, as well as multi-threading. Instead, what we're going to do is we're going to look at some items from my personal sort of like everyday work. I've sort of taken some examples of small problems that we run into and that we've solved Pythonically, and just sort of explain here. Here's the situation I was in, and here's how we use Python to solve it, just like that. So a little bit about myself. My name is Jonathan Solis. It's nice to meet you guys. I'm a senior software engineer. Been doing this for about 7 years, almost 8 years. I'm primarily a front-end engineer, and actually JavaScript is my main language. Python is my second most frequently used language after JavaScript. I mostly focus on React, but I also love Python, and I'm here to give you guys the perspective of a front-end developer. I mostly work with Python in AWS context today, so I can give you my perspective on that. In 2014, which seems like forever ago, I graduated with a BA in English and a BA in Informatics with a cognate and human-computer interaction from the University of Iowa. So not only proficient at programming, but I'm also pretty good at naming variables. My experience with Python includes that I learned it sort of as a lingua franca in college. That's what they taught at the computer science department at the University of Iowa. I've used Python to scrape data for machine learning purposes. I used to work at a startup company, and one of my roles there was scripting scrapers of documents to get the data into machine learning algorithms. This is my one claim to being published. I know you guys are all grad students, so you guys probably have more publications than I do. All I have is one white paper with my name on it, but it was leveraging Python that got me that one credit, so I'll take it. So today, I use Python in the context of AWS Lambdas as a part of our application serverless architecture. So like Amir said, my employer is a company called Aquid, which is based out of Iowa, but they are sort of a provider for other companies. I'm on assignment at John Deere Financial. So my day-to-day work is working with the database team at John Deere Financial. What I do is I create applications that are front ends that sit in front of like the important layer of databases at the heart of John Deere Financial's business, so that we can provide business logic as part of people's sort of day-to-day procedures, processes, stuff like that. So we use React for the front end framework, and then we use AWS architecture. You may or may not be familiar, but we use the standard, it's called an API gateway, which connects to Lambdas, and then those Lambdas, which are written in Python, they go out and they talk to our bevy of databases. So a lot of the work involves running Python to communicate with databases, massage data, cement in business flows, and manage all of that. So quick poll. Now that you guys know a little bit about my experience with Python, if you guys could sort of do a self-assessment of what your Python skill is, that would help me sort of calibrate this conversation going forward. If you look at the right side of the screen, there is a scale going from 0 to 4, 0 having no experience at all, 1 meaning that you dabbled, 2 means you're comfortable coding, and 4 means you're Ron Swanson, and you probably know more than I do. And I suppose we can just put that in the chat. Is there a chat function here?
Yep, there's a chat function over there. I could create a quick poll too if you want, but it might just be easier to, yeah, everyone's already going for it, so we're good.
Okay, so I'm seeing a lot of zeros and ones. There's a 0.05 in there, which is good. 0.05 is a good place to be. And it looks like a handful of twos, 2.5. Okay, cool. Umir, how many people did you say were in today's session?
So we have about 57. Yeah, it's including you and me. So I would say probably about 55, 54.
Okay. Well, it looks like they're starting to trickle down. Yeah, so I think, just eyeballing it here, it looks like most of you guys are beginners, which is great because that means that this session should be valuable to you. I guess my one concern was that you guys were already kind of pros and looking for something more nuanced and niched, but I think this will be appropriate. So thank you guys for doing that. Oops. Okay. Let's go on here and let's take a 10,000-foot view of Python. So what is Python? Python is an interpreted, high-level, general-purpose programming language. Its design philosophy emphasizes code readability. Has a notable use of indentation, so white space matters in Python. Unlike a lot of other languages where curly braces are used to denote like the scope of your function or whatever you're trying to write, Python uses white spaces. Its language constructs, as well as its object-oriented approach, aim to help programmers write clear, logical code for small and large-scale projects. So Python is both a functional language, can be used as a functional language, and it can also be used as a traditional object-oriented language. So it's very, very versatile. It's one of the most popular programming languages for both beginners and for people who are super advanced because of how flexible and powerful it is. So learning Python, great life choice. I definitely recommend it. Couldn't recommend it more, honestly. I guess the only thing I could probably recommend more is JavaScript, just because that's my first love. But today we're talking about Python, and today Python is on major version 3.9.4. One thing to keep in mind about Python is that it has evolved over the years. It was originally created in like the late 80s, early 90s by this handsome Dutch man right here. His name is Guido van Rossum. He made Python. He's worked at Google, Dropbox, and Microsoft. He actually retired from Dropbox and came out of retirement a year later to go work at Microsoft. He named the language after not the snake, but the Monty Python TV show, which was popular at the time, I suppose. And he says it's because he was feeling slightly irreverent. Like I said, it's a very popular language. Depending on what sources you look at or what stack you're kind of trying to read, it might be the most popular language. But according to Stack Overflow, it's the 4th most used language according to their developer survey last year. It trails behind the web wonder twins, JavaScript and HTML. Just go together like Hansel and Gretel, and the ubiquitous data query language SQL. SQL is also, different part of the stack, highly used, it's everywhere. Now, Python is the 4th most used programming language on Stack Overflow. If you look at some of the numbers for like salaries and stuff too, Python is also usually ranked highly as like one of the more high income programming languages to get a job for. And that typically has to do with the fact that Python is very heavily used in the machine learning and artificial intelligence fields, which are high paying jobs. So those things go hand in hand. Common applications of Python include web development. So that's where you'll find me in the web development area of Python. Scientific and numeric calculations. There's some really advanced data processing libraries that you can use in Python for scientific purposes, for data science. You'll find Python used heavily to support the backend for business applications, which is where you can find me there too. Python's also used for games and 3D applications. This just came to me for whatever reason, but the game Civilization 4, I believe, is actually written mostly in Python with like the core game logic is written in Python with sort of like the graphics processing stuff offloaded to compiled C stuff. I can't go into the specifics, but you'll find that like understanding Python could give you an edge on understanding how certain games are created, which could be a way to sort of reverse engineer if that's something you're interested in. Next is network programming. I think you can use Python on like a Raspberry Pi. If you want to like be a hacker, you can go, stick your Raspberry Pi into some network hub somewhere, and Python's what you're going to be, what you can use to make things sort of easy for yourself. Number 7, desktop GUI applications. I don't think Python is used as much anymore for desktop GUI applications. I could be wrong about that, but my sort of feeling of it is that there are other languages that are preferable for GUI applications, including Electron, which is Node.js based, but that's more there than here. So I guess one last point here I want to touch on is talking about the version. So I said we're on major version 3.9.4 today. Most of the time I work with Python 3.7. That's because it's the latest version that's supported by AWS, which is the context I work in. So that's the big bottleneck for me. Otherwise, I would be on 3.9.4. That being said, the differences between 3.3 and 3.9 are like not make or break. They're not deal breakers. They're just some enhancements or new features that are for people working sort of in very niche areas of programming, perhaps for machine learning or data science. Any version of Python 3 is worth using and learning. However, sometimes you do have to use Python 2.0 simply because that might be the version of the language you're using in whatever organization you enter or whatever project you start working on, in which case you have to study the differences between those, which are subtle but important. Wait, why do people love Python? So I think there's 4 main reasons why people love Python. It's easy on the eyes. Python is some of the smoothest, well-spaced, tightly written syntax you're going to find out there. So there's no random curly braces to have to remember to open and close. It's readable, which is very important. Programming languages are for people, not computers, and it does a good job of being human-friendly. Number 2, I would say, is a robust, open, and these are just my opinions, by the way. There's lots of reasons why people love Python, but if you were to ask me, and we are, so these are my thoughts. Number 2, very important, a robust open source community. They have very well-developed open source packages in Python. They're maintained and updated by communities of absolute nerds, units, who hone these libraries to a razor-sharp edge. So now it's easy to stand on the shoulders of giants and focus on applying the language to real-world problems. Number 3, it takes out its own garbage. You don't have to manage memory in Python. Python is an interpreted language, so a lot of the heavy lifting, sort of raw computer sciencey stuff is neatly tucked away under the hood, and that's a great thing. Developers can bypass complicated compilers that you'll find in languages like C, C++. Those are themselves a world of pain, and quickly and efficiently start coding on any machine, which dovetails with point number 2. And then finally, it's powerful and it's flexible. So there are several tried and true mechanisms to gain greater performance if you need to by leveraging compiled Python extensions, which you can write in C once you get to that level, that are pre-compiled to optimize for certain subroutines and tasks. So even with Python as your primary programming language, you can still hit that sweet spot between performance and flexibility down the road. So it's worth learning, even if you think that performance is your utmost priority. So what are we getting ourselves into with Python? I'll be the first to say that the best way to learn Python, as with any programming language, is to dive into the deep end and get your hands dirty, solve practice problems that require you to learn and understand certain aspects of the language's syntax and features. You know, there's so many websites out there you can go to. You can go to HackerRank, you can search Python practice problems. In the materials for today, I included a link to a GitHub repository, which I thought was really interesting because I think it answers some of the really common questions that crop up when one starts learning this language in the README. And I think that if you start studying Python deeply, you're going to have these questions. And I think that that document does a really good job of addressing those. That being said, watch out though, because the programming examples in there are written for version 2.7. That's my only gripe. So keep that in mind. So you're also going to have to understand sooner than later how lexical scoping works with regards to variables, namespace, classes, and functions. These are the sort of core concepts that Mira was getting at earlier. They're fundamental to solving all but the simplest problems. And I would suggest, reading the documentation, of course, but approach it from both angles. Read the documentation on the concepts, but then also go practice them on apply them to problems, and come at it from both directions. So for that reason, we're not going to spend too much time on just kind of rotely, going through the concepts. We're going to look at problems and work our way backwards. Okay, where are we? So learning Python, all this is going to take hours, days, weeks, eventually years to master. You need to do something for 10,000 hours to master it. I don't think I've even done Python for 10,000 hours. So what can we hope to accomplish in our short time together? So today, what I'd like to help illuminate is what parts of Python are worth mastering first and foremost. I want to kind of grant you guys a peek into the mundane duties of a software engineer, and do some live coding for you in order to highlight the parts of Python that I personally keep coming back to. That being said, these sort of what I like to call bread and butter techniques are only the tip of the iceberg. I encourage you to master these right away, though. I promise that these salt-of-the-earth fundamentals will be the bedrock for any line of work that you find yourself in, and will serve you well no matter how complex your application gets. But before we get to my day-to-day examples, let's get our bearings in the language with some computer science classics. We're going to start with a Python implementation of Fizzbuzz and binary search, which are what I would call two extremely common programming interview questions. Turns out programming interview questions are actually pretty easy. There's a passage from this book, Algorithm for Interviews, which I'll read here actually in a minute. But the point is, these kind of problems are the great filter, I think, for a lot of programming interviews. And the great news is that they're easy. They're not difficult. Once you sort of understand them, you're never going to forget it. It's like riding a bike. Okay, so the two problems we're going to look at: Fizzbuzz. I consider this the OG interview question. I had a friend once who got like a job at like a government contract. I asked him how he did it and like what the interview process was like, and he said that they made him code Fizzbuzz and he got the job. So I'm really not joking about what makes a good entry-level programming interview question. So the problem, if you can't recall or if you don't know, is you got to write a short program, and it's going to print out each number from 1 to 100 on a new line, and for each multiple of 3, print fizz instead of the number. But if it's a multiple of 5, print buzz instead of the number. And then for numbers which are multiples of both 3 and 5, print fizzbuzz instead of the number. And that's it. Number 2, we're going to do an iterative binary search as opposed to a recursive one. And let's get started. So at this point, let's talk about if anybody has any questions, and then I'll go over the IDE pie chart, and then I guess if anybody has any questions, we can answer those too. So at this point, does anybody have any questions?
Quick question.
Sure. What's your name and what's your question?
My name is George. I'm a PhD student in mechanical engineering. Yeah, you mentioned AWS, and I know a couple of friends who have written so many certification tests within AWS. What kind of opportunities does this open you up to?
That's a great question. Yeah, I think it opens you up to a lot of opportunities. AWS, very quickly, the web world is migrating towards cloud infrastructure. Traditionally, people would have like run servers, like Java servers, either their own servers, or maybe they had something provisioned in the cloud. And they would run those, but more and more people are moving to a serverless architecture. And so a lot of jobs are going that way too. And with AWS and other cloud infrastructure services, the two most common programming languages that those are implemented in are Python and Node.js, which is JavaScript. So I would say that field is actually increasing right now. So and Python is at the heart of that. And actually for day 2, I was hoping to get more into the nuances of AWS and Python as well.
Thank you.
Yeah, no problem. I'll take a sip of water here. Anybody else?
Hey, Jonathan, there's a question in the chat for the download link for the Python scripting. Is that just the same thing that you sent me?
Can you run that by me one more time?
There's a question on in the chat for the download link for the Python script.
Oh, okay, yeah. So if you've downloaded PyCharm, you might also need to download Python itself. Is that the question? Can you please share the link to download the software for Python scripting to get started? Yeah, so for that, I'll just share here. I believe you can just go to python.org and downloads now. I'm not privy to what operating systems you guys are using, but I believe you can download like like the installation managers for Windows and Mac and even Linux. There's a lot of ways to install Python on your machine. This is probably the most direct way to do it. Just to get started, we want Python version 3.9.6. So this is python.org. Now, once you've downloaded Python, this is actually not a bad segue into this guy. You're going to want to open PyCharm Community Edition. And when you open PyCharm Community Edition, I believe it's going to ask you to set up Python at that time. Now, if you go through the standard installation procedure, it should pre-populate that list with the path to the Python executable. So it should be pretty straightforward. And then when you open your IDE, you just see something like this. Does that answer the question? And does anybody else have any other questions about just sort of getting to this part? Okay, cool. So I'll give you guys a grand tour here. So this is PyCharm. I used it's from a company called JetBrains. I used the professional version of PyCharm and WebStorm for work day to day. The community versions are great too. I definitely recommend investing earlier rather than later in learning these tools. My tool of choice is PyCharm, but there are other great integrated development environments out there. There's VS Code, and there's Atom. There's a ton of them. They're all great, and I suggest investing in yourself by learning these tools inside and out. Sometimes downloading and installing a program becomes the first hurdle. That's true. It might be good to find a Python buddy to ask questions if you get stuck during installation. There's also Anaconda, which can do a Python install for you and is robust enough that it works around a lot of issues. That is true. I've never gone the Anaconda route myself personally, but I do know it's a good solution for managing versions of Python. All right, so if you'll direct your attention to the screen, I'll just point out what you're looking at. There's 3 panels here on the far left. This is a file explorer. So we've set the root of our project to this particular directory. It's my home directory / PyCharm project / Python project. And you'll see that it has some files in it. You double click these files and they'll open up here. And they'll open up here. And this is a text editor. Now it's a fancy text editor that includes syntax highlighting specifically for code. You'll see that it does a lot of work by coloring code. So like in Python, a comment starts with a pound symbol, hashtag, and that means it's not actually interpreted by the program. So you'll see in the IDE that it's grayed out. That means it's just kind of for the developer. Certain language constructs, such as def, if, these are language keywords. These are highlighted in orange. Arguments for your program are going to be here in blue. So these are like your variable names and stuff. Print, this is a built-in function for Python. It's also, since it's a function, it's purple. And there's a whole rule set here. And once you start working with it, you sort of get the hang of it. All right, and at the bottom here, this is the Python console. So Python, like I said earlier, is an interpreted language. You can execute Python, and what you'll get is a console here. And so this code that's up here, I could copy and paste this guy directly into the interpreter. And now,
Hey, Jonathan, we got a quick question on the chat. Can they use Anaconda or Jupyter to work on this webinar?
so it doesn't matter where you get Python from, as long as you have the Python executable on your machine somewhere. So the answer is yes, but I'm not familiar with how the process works for getting those on your machine. If anybody else has know-how on Anaconda or Jupyter, could they maybe work together on that one? I guess, what do you think, Amir? Would it be worth trying to download? I guess my recommendation would be to go to Python.org, download the version of Python for your machine, for your operating system, put it on the default path. If you do it that way, and then you open PyCharm, PyCharm will almost always be smart enough to know where to look for that, and you should be set up just like that. So all you need is you need to download the Python interpreter or the Python executable, and then configure PyCharm to use that version. And then that version will be used to run and execute the Python console and any code that you want to run locally. Yeah, that's true. I understand. A lot of times, like the integrated development environment that you're using, if it's not the same as what you have in front of you, it can be distracting or a little confusing. I would like to try to just focus on like the core of it, which is you want a text editor. Idle is the built-in text editor for Python, or you can use an IDE here. And you can also run a Python console from Idle as well, which just comes pre-built with the Python executable and Idle. I think you can run the Python console from the context menu or the menu of the Idle text editor. It's been so long since I've used it. Hopefully that answers the question. But what you're looking for, what you want to get to is you want to have a Python console that you can play around with. So here on my screen, I have a Python console, and I've just pasted in a function called print high. And a function is just created with the keyword def, as in define, defining a function. We're going to call this one print by. And it's going to take one argument. The argument is going to be the name of somebody you want to say goodbye to. You're going to press enter. Remember, white space counts, so you want to be at least 4 spaces away. It's going to do that for you automatically most of the time. And then in order to print something to the console, you use the print command, and that's just print with parentheses. And then we're going to use a string feature called an F string, which stands for, I think, format string. So it's a literal character F followed by quotation marks. Now inside your quotation marks, you can print whatever characters you want. You can say goodbye, colon, and then when it's an F string, when it has that little F character in front of it, you can open up curly braces inside of your string, and then you can insert a regular Python expression. In this case, what we're going to do is we're going to take that variable from the function argument, and we're just going to insert it into this string so that when we call this function, print by, we're going to say, oops, print by, I don't know, we'll say John. Then what comes out is goodbye, colon, John. All right, Fizzbuzz. So let's do it like this. I'm going to open up a new file. I'm going to call this fizzbuzzlive.py. and I hit split and move right there. So all I'm doing is I'm looking at two files side by side. And we're just going to re-implement this really quickly. So what we're looking at here on lines 22 through 32, when I was preparing for today, I wanted to just run through implementing Fizzbuzz by myself just to make sure I wasn't too rusty. So this was my just like first go at it. And so what I said was for arg in arg. So here's the first language construct we're going to look at. This is the regular for loop. Now args is whatever we're passing into this function. Because we're looping through it, we're expecting it to be iterable. And in Python, most commonly, things that are iterable include lists. So list example, and a list looks like that. It could be a tuple, which is a kind of list. So those are your list types, and that's what args needs to be. So for arg in args, and then here, this is just some simple math, right? If our argument, which we're expecting to be a number, between a 1 and 100, modulus 3 is equal to 0. Now, the modulus operator, if you're not familiar, is basically division, but the result is going to be the remainder of whatever you're dividing by. So if you had 3 modulus 3, your result would be 0, which means it's divisible and a multiple. And if your remainder was 1, maybe you did 4 modulus 3. So that's one little like classic programmer approach to checking to see if a number is divisible evenly. So now we're inside of an if condition. Ultimately, the building blocks of like any programming languages are loops and conditional statements. So that's what we got here. We have a loop and we have a conditional statement. And we're saying inside of this conditional statement, all right, if it's divisible by 3, that's fine. But I really need to know if it's also divisible by 5 as well, because if it is divisible by both 3 and 5, that's the case where we want to print Fizzbuzz. All right. But if it's not divisible by 5, that means it's only divisible by 3. And so we print Fizz instead, and that's what the rules wanted. Next, we have this weird looking word called elif. It's kind of like a, what's the word, portmanteau? It's like when you stick 2 words together, of the words else and if. So else if. So else if arg modulus 5, which was the other condition the question asked for, equals 0. And that's the case where we want to print buzz. Now, if neither of those conditions are satisfied, we're just going to print the argument, which is a number. So that's a pretty simple, straightforward Python function, and basically mixing together a loop and conditional statements like that. That's the bread and butter of all programming, and especially Python programming. So if you know that, you're in good shape. We can do a quick test on this guy down here. Here's what I'm going to do. I'm going to right click on this file. I'm going to click this button that says Run Fizzbuzz Live. That's the same thing as if you were to go to the command line, cd to this directory, and then write Python, and then the name of the file. And quick configuration change. I want to run this with the Python console. And otherwise, if it just runs on the command line, the program is going to run and it's going to exit because there's nothing keeping it alive. By running it inside of the Python console, it's going to run the file and then keep the interpreter alive so that you can interact with it. All right, the next thing we're going to do is we're going to create an argument for this function. Now, the problem wanted us to run through numbers 1 through 100. In Python, there's a built-in function called range, which will allow you to generate a list of numbers in the range of x to y, where x is your first argument and y is your second argument. So, numbers, we're going to set that equal to range 1 to 100. Now, if we type in numbers, actually, you know what? Quick change here. We're actually going to do a quick Python list expression comprehension. So we say x for x in range 1 through 100. And there's our list of numbers. This is called a list comprehension. I'm going to talk about these later again. This is cool if you know how to do list comprehensions. What I just did is the equivalent of saying numbers equals an empty array, and then writing a for loop where you say for x in range 1 through 100, which is, once again, that's a for loop. So every x is going to be every number between 1 and 100 as it loops through them. And then what we're going to do is we're just going to append whatever number it happens to be to that empty list of numbers that we defined up there. And once again, it's 1 through 100. Anyway, so that's just to get a list of numbers so that we can call our cool Fizzbuzz function. And then here's the output. You'll see, you can check it for correctness by making sure that numbers that are only divisible by 3 say fizz, numbers that are only divisible by 5 say fuzz, and numbers that are divisible, like 15, by both 3 and 5 say Fizzbuzz. All right, so that's my my approach to Fizzbuzz. Does anybody have any questions on that or anything we just talked about? Cool, that's great. So just for demonstration purposes, that was one way to do Fizzbuzz. Here's a slightly different way to do Fizzbuzz. In this version, we still have our classic for loop for variable in range, and then in this case, this version of Fizzbuzz accepts a number, which we're calling n, and it's saying n plus 1. So if we gave it the number 100, this would be range 1 through 101, and so this would loop 101 times. And then this block of code would run during each loop, and it would say something like if I is, divided by 15. And the reason this is a little more efficient is because it only has one level deep of conditional statements. So it's if, elif, elif, and in my other case, we had a nested if else statement, which is perfectly fine. This is a little cleaner. So it's going to run through these conditions. It's going to do whatever it says inside of here. If the condition is met here, if the condition is not met there, else if the condition is met here. If it's not met there, it's going to look at this one. And finally, if none of those previous conditions are met, it's going to run whatever is in the else block and nothing else. So at most, only one block of code here can be run per loop, per iteration. And this probably sounds all boring and stuff, but let's say you were making a game and you wanted to you wanted to check to see if somebody's treasure was going to be really good or not. And I'm making this up on the fly, but like, let's say you wanted to have randomized like the quality of treasure you're giving to somebody. Like perhaps the character has a hidden statistic called luck, which they build up in the game by doing, nice stuff for people. The higher that luck integer, you could create a function that says if their luck integer is, divisible by 15, which I don't know if that would be useful or not, but you could say anything in there. You could say if it's higher than 100, then their chances of getting a good item go up, and you can add a little bit of randomness to the equation. So hopefully that helps get the juices flowing. Finally, there's one last version of Fizzbuzz, and I know Fizzbuzz is rather boring, but I wanted to talk about this one too. The truth is, in real life, coding can be kind of boring. And it's not just the correctness of the program we care about, it's also how easy it is for other developers to use it, and for ourselves in the future, which I would almost consider like myself 2 weeks from now to be a whole new person, a whole new developer. I'll probably forget that I wrote this code. I'll come back to it and I'll be like, who wrote this crappy code? Oh wait, it was me. So we don't want that to happen. So what we want to do is we want ourselves set ourselves up for success in the future. So this version of Fizzbuzz right here, actually, I need to put this inside of a definition. Define Fizzbuzz 3. This version of Fizzbuzz also has a for loop, and it's looping through our numbers 1 through 100, and 1 in this case. But they have this extra little thing going on here. They call it a modulo list. And so this is a list. You can tell with the square brackets and the comma separating the items of 2 what are called tuples. Quick sidetrack. The difference between a list and a tuple in Python, they're both very similar. They're both lists basically, but the difference between a tuple and a list, I'll describe it this way. Let's say you had a barrel of monkeys. Well, a list, you can keep appending more monkeys onto the end of the monkey chain. You put 1 monkey, 2 monkeys, 3 monkeys, you chain them all together. Their arms are interlinked. You got your monkeys. In a list, you can take a monkey off the end. You can put a monkey at the beginning. You can take a monkey out of the middle and make those other 2 monkeys come together to fill the gap. That's a list. A tuple is, let's say you took a soldering iron and you soldered 2 monkeys' arms together. So now those monkeys are inseparable. What you've done is you've created a tuple. So it's a list that's immutable. It can't change. Once it's been set, you can't append to it. You can't subtract from it. It's just like this list of things where you still have discrete items in it. You still have 2 monkeys, but they are fused at the hip. So they can't be separated. The reason we do this is, there's lots of reasons we do this, but the reason you do it sort of on a day-to-day, sort of mundane basis is because you want to communicate to the developer and to the program that these pieces of data are intrinsically linked together and they should not be separated. For instance, in Python, when we do a database query, we typically get back a list of tuples, and each tuple represents a row of the database. And so we want to make sure that that data doesn't change unnecessarily, because all that data that came from that database row is linked together. It is one row of data. So we make it a tuple, and then we pass that tuple of data around. And if we need to modify that data in the program for whatever reason, that's when we're going to do something like we're going to copy that tuple into a list. And so then it becomes a list, and then you can work with it.
have a question. Can we use dictionary in here?
Yeah, Python dictionaries are an important data type in Python as well. For Fizzbuzz, I wouldn't recommend using it.
Oh, okay.
And we'll get to dictionaries in a minute here with another problem. But thank you for asking. So hopefully that answers the question. Did I answer your question, by the way?
Yep.
Cool. So the only difference between the other two versions and this version is that this version includes a list of tuples. And instead of including the logic explicitly where we say, you know, modulus 15, modulo 3, what we're saying is I modulo mod, and we're looping through each of these tuples in this list. And we're saying if the number we're iterating on, like let's say we're on loop number 10, the number is 10, 10 modulus, and then what this is doing is it's accessing the first item from the tuple, 0. In Python, arrays and lists are 0 index, which means the first item is always 0. So we're getting that number and we're comparing it to whatever we're on. So the 10 modulus 3, if that results in 0, then we print the string. And what we do is, or what we're doing is we're appending modulus 1, which would be the second item in the tuple, fizz, to a string. So what we're doing, we have empty string here. This plus equals means we're adding this to the end of this string. And as the loop's over, that string is going to keep growing and growing and growing. Anyway, at the end of this, we have this if statement where it says if print statement equals an empty string, we just print I, which will be the number. So the case where this is an empty string is where the number we're on, like 10 or 12, isn't cleanly divisible by either 3 or 5. In that case, we just want to print the number like we do for the rest of the program. So this is a slightly more complicated version, but the reason that this is nice, the reason that you like to see this kind of thing in the real world is because it's extensible. So let's say later on the business requirements change. Your boss, she comes to you and she says, hey, you know, Jonathan, remember when we had, you know, all those cool Fizzbuzz strings and they were working on 3s and 5s? Well, it turns out the world has changed. The ground has shifted underneath our feet. And now we actually want to make those divisible on 2s and 8s or 2s and 9s. And we're like, oh, like crap. Well, now I'm going to go back and change the program. You know, and you're going to go find the places in your program where you were using the numbers 3 and 5, and you're going to replace those. And you don't want to do that. Instead, all you want to have to do is come into this list in your program and swap out the number 2 here and the number 5 there for the new numbers. And that helps make your code flexible and adaptable. So this is the version of Fizzbuzz that would be a great solution if you were like kind of doing an interview, because the person who's interviewing, if you explain it and justify it that way, the person who's interviewing you will almost certainly see the value of that justification. All right. So recap, we learned about the for loop. We learned about conditional statements, if, else, elif, the modulus symbol, the equals symbol. I didn't really talk about it, but when you have 2 equals symbol next to each other, and this is important, that's not, this is actually equals. This is actually saying so the left side of my equation is equal to, it's asserting that it's equal to the right side of my statement. When When it's just the one equal symbol in Python, that's called an assignment operator. And that means we're assigning the right side of the operator to the variable on the left side. We also looked at the range and print built-in functions, which have, their specific jobs that they do. And I believe that is it. All right, any questions on those language constructs? Cool. Okay. Hey, Amir, how are we doing on time?
Oh, we're doing well. We have about 28 more minutes. So if there are any questions, we would definitely, like a little bit more interactive session with whoever's left. Yeah, just feel free to ask some questions.
Cool.
Or Jonathan, if you have more content, yeah, just go for it.
Cool. Yeah, I think I have enough, definitely enough to build time. All right. So let's take a look at a different problem. This is binary search. Binary search. Binary search, classic computer science algorithm, runs in big O notation of log n log n, which is log n. So it's efficient. In essence, what you're doing is you're cutting your search area in half. So this algorithm works best on pre-sorted data. So, the classic example, if I recall correctly, is like a phone book. So let's say you have a giant phone book with everybody's name in it, sorted alphabetically already. You want to find Linda from high school or whatever. Well, you open the phone book up to the very middle and you ask yourself, is the name I'm looking at before or after Linda in the alphabet, or is it Linda? And if it's after Linda in the alphabet, get rid of the second half of the phone book, and it's in the first half, and then you do the same thing basically. You go to the halfway between the middle and the beginning. You ask yourself, is the name I'm looking at Linda? If it's not, tear off the half that her name is not going to be located in. Hold on. So on PyCharm here, we define binary search. The first argument, I'm going to say this is what we're looking for. We're looking for something. So we're going to call this variable. The second argument is a list of numbers. That's what it is. And here's a new Python concept. When working with a function, you can define a default argument for a variable so that later on when you go to invoke the function, you don't have to supply that argument. But a default variable would be like use the equal symbol to assign this default variable. In this case, I just want to say that the list of numbers is this array x for x in range 1 through 100. And I could say default list variable. I could type x for x in range 1 through 100. So when this program runs, it goes from top to bottom and looks at this line and says, all right, we're going to set this default list to this comprehension over here. And then it's going to see the definition of the function. It's going to know that the default list of numbers, which means if we don't supply that argument, it's going to use that default list instead. Then we can start implementing the algorithm itself. Now, the way this algorithm works is you need to keep track of the low end of your range, which we know is 0. I guess I should put that in here. The highest number, which we are setting to the length of our list of numbers, -1. And then we want to know what the middle of this list is. At the beginning of the function, we're not going to know what that is. This particular version of binary search, we're keeping track of the number of guesses it takes to pinpoint the number as well. That's not standard, but we're doing that for demonstration purposes. Okay, and then this algorithm operates on the while loop. We use the while loop. So there's 2 main loops in Python, 2 main loops in most programming really, and the while loop is the other one. So the for loop, you give it a list of things to loop through. You give it a list, you give it a barrel of monkeys, you tie them all together, you say, go through each of these monkeys and do something to each monkey. I don't know what you're doing, but do something to each monkey. Now, when you have a while loop, you specify a condition. And every time that loop iterates, it's going to check the condition and it's going to say, is that condition true or not? And if it's, as long as that condition continues to be true, the loop will continue to run. People get themselves into trouble here because sometimes their conditions never evaluate to false, in which case you can have what's called a runaway loop, which leads to memory leaks or programs crashing. So you got to be careful to make sure that the condition you specify in your while loop will terminate eventually. In our case, we're tracking to see if the low value is less than or equal to the high value. Now, at the very beginning, low is 0 and high is going to be 100 or 99, I guess. So they will not be the same. So it's going to loop at least once. And then inside of the loop, we're going to keep track of a number of guesses. So the very first time it runs, we say the number of guesses plus equals 1. Plus equals 1 is the same thing as saying the number of guesses equals the current number of guesses plus 1. So these two are equivalent syntax, or equivalent functionality. This is just a slightly more Pythonic way to say it. The next thing we're going to do is we're going to assign the middle value. So we've opened the phone book and we're in the middle of the phone book, and we're going to say, all right, the place that we're at right now is the high number plus the low number, divided by 2. The double division symbol just means it's going to automatically round the number. So like, let's say it's going to throw away any decimals that you might have because we don't need those for this purpose. We basically want to work with integers here. The next part of this algorithm says if our list of numbers, we're going to go to our list of numbers, we're going to access the number that's at the index of our current middle. We're going to ask if it's less than the number we're looking for. And if it is, then we're going to set that low number equal to our middle plus 1. So we basically, in that case, throw away the bottom half of the phone book. We know the name we're looking for is not in there because we know it's sorted alphabetically. We tear the whole thing out folk style and just toss it in the trash. Else if our list of numbers. And we go to the middle and we ask, is the number in the middle greater than the number we're looking for? If it is, then our new high number becomes equal to our middle number minus 1, sort of the inverse of the other case. Finally, if neither of those conditions are met, logically, what we can deduce is that x must be the number in the middle. So that would be the case where like, you know, what number is in the middle or what letter is in the middle of the alphabet? Like L or O? Let's say it's O. I don't actually know, but like, let's say it is, and this person's name is Oren. We open the phone book to the middle, and that's the name we find. That would be this case. In that case, we want to break out of our loop. We found our name. And so this special word here, break, this means that this is sort of an escape hatch for a while loop. You know, you could write a while loop where it said while true. Now this while loop will continue to loop on forever and ever and ever and ever and ever by default. But if something inside of that loop triggers this break to happen, then the loop will terminate. So that's another way to get out of a loop. Finally, what we're doing here is we're returning the number of guesses. By the way, I did take this example from the binary search example in that Python interview questions repository that I was shared with you guys earlier. There's a bunch of like good problems in here. This is sort of a version of the binary search. Typically with the binary search, you want to return the actual value you're looking for, like an any data associated with it. But in this case, it's asking how many guesses did it take to get the number. All right, quick note on this syntax down here. So what this means, if underscore underscore name underscore underscore equals underscore underscore main underscore underscore, this is what they call like magic Python syntax. In Python, if you ever see a variable or a name that has 2 underscores before and after it, that's how Python sort of internally keeps track of its namespaces. And what this is saying is that if this is the file that was run like from the command line, or like the file that was invoked directly, if it's the main file for the script, then we're going to run some special code. And that's because it could be the case that a file in Python is imported into another file somewhere else that's actually like the main program, and the file you're working on is just like sideshow Bob or whatever. So you can have a conditional statement that says, if this is the main attraction, run this code. If it's just being imported for pre-game entertainment, we're going to ignore it. In this case, we're going to run this file directly, and it's going to run this. I won't spend too much time on this, but what it's doing is it's importing a library, a built-in library from Python called doctest. Doctest basically allows you to run some tests written inside of a doc string. That's what this stuff is up here. You see there are 3 quotation marks here, 3 quotation marks here. That means this whole thing is a string, technically. When you put it at the top of a function, you call these doc strings, document strings. Typically, you use this to annotate a function so that if another developer comes and reads your function, you can leave notes about what it does, or even you can do one better. You can actually write test cases where this is like the test you want to do, and this is the expected output. So you see here that he's testing that when you run the binary search function and you give it the number 50, and of course we're looking at a range of 1 to 100. Well, if you open the phone book directly to the middle, you should find it right away, which means that the number of guesses should be 1. So that's a really easy case to test right there. And that's how the test gets invoked with this method. This method will return an object which will have some data on it about whether the tests failed or passed. It's associated with the results.failed equals 0, which means they did not fail. Or we'll print pass. So When I go into Python or I go into PyCharm and I run this file, it's going to pick up on the fact that it's a doc test, and it's going to run these unit tests. These are called unit tests. And it's going to say, hey, all 5 of the tests that were written there passed. That's beautiful. You love to see stuff like that. Later on down the road, if somebody needs to change how this function works, they can modify what they want to, and they can rerun the tests. And if the tests still pass, that probably means you didn't break the code, probably. All right. So there you have it. Binary search and Fizzbuzz. Hopefully, you picked up on some of the language features there, the while loop, the conditional statements, the return statement, how you define a function in the first place, how you pass it arguments, how you assign variables. You'll notice that it's very terse. There's not a lot of extra cruft around the edge. Like for instance, in other languages like JavaScript, you have to define a variable like this, where you say const variable name equals something, and then this keyword is like what kind of variable it is. In more strongly typed languages, such as Java and C#, you have to declare the data type of the variable first. So you say string my variable name equals this, and whatever you put over here has to be a string. Python's not like that. It's much cleaner, more terse. You just have to name the variable, and then it will figure out what the data type is, so you don't have to worry about that. Okay, guys. Looks like there's about 10 minutes left. Is that right, Amir?
Yeah, about.
Okay. My next section was going to be some real world problems, where I was going to talk about just like actual problems I've run into at work recently. But I don't think we have enough time to really dive into that today. We can save that for tomorrow. And I guess I would just like to know if anybody has any questions or follow up, or maybe just thoughts about Python in general.
I was wondering if you could probably elaborate a little bit more on like what sort of stuff we will be covering tomorrow, just so everyone has an idea of what to be prepared for.
Yeah, no problem. Let me pull up my notes. Okay, so in addition to some of the real world problems, I wanted to talk about regular expressions. Irregular expressions are very powerful ways to impose order on unruly strings of data. In the real world, you're getting data thrown at you from all sorts of angles. It could be from sloppy databases, from user input that's not validated correctly. There's all sorts of messy edge cases. Irregular expressions are a very powerful way across all programming languages, and Python is no exception, to handle those kind of use cases. I wanted to talk about exception and error handling. Exception and error handling is a concept in most programming languages, where when things kind of hit the fan, your program could blow up. We use exception, what we call try except blocks, to put bumpers on parts of the code, so that if something does go wrong, we can handle those situations gracefully. I want to talk a little bit about static analysis, linting, and code styling. Static analysis is sort of a burgeoning field in computer science. It's very important, especially to developers, because it allows your, how do I say this? It'll analyze your code for you and basically give you a hint or heads up if something you wrote is gonna throw an error at runtime. So while the program is actually executing, it could be the case that what you wrote is like valid code, but the logic behind it is such that when you run it, it's gonna throw an error. And so static analysis basically assists the developer in catching bugs earlier rather than later. And then I just wanted to kind of go over some resources for learning Python, going deeper, just some suggestions on resources that I've used over the years to get familiar with the language, and any recommendations in that area. And that's it.
There's also a question about, do you have any homework that might be useful to look at in advance for tomorrow or anything like that?
Well, what I would suggest is I would suggest typing out the examples that I just did, and I can send those along to you, Amir, if you want to forward them in an email. I'll go through them yourselves, try to get them to run, make sure you understand what they're doing. That's really the beginning, I would say, if you're starting from ground zero. And then I'll also drop a list of Python topics, such as list comprehensions, exception and error handling, links to the documentation, where you can go and sort of get an overview on those things.
I have a question. What kind of an IDE software would you recommend for Python? Is it just a PyCharm, or like I'm using Atom right now, but like which one is most widely used in industry is my question.
It's a great question. Ultimately, the IDE is a matter of personal choice. Some of them are completely free. Some of them are free but have paid versions. Some of them you have to pay for. I think a couple of years ago, I might have been a little more adamant about suggesting PyCharm for Python. But nowadays, even the open source IDEs, I think such as Atom, are very advanced and have a good community of plugins that you can use to enhance the functionality. So I would suggest looking up in Atom plugins or extensions for Python. And you know what? If you're not sure which one you like, you can download multiple ones. If it's the paid one, you can download the free version of it, play around with it, kind of get used to it, and see what works for you.
Okay, thank you.
Do you have any other questions? Well, seeing none, I guess it will be a good point to come to a close for the day, but we're going to have plenty of stuff to discuss tomorrow too. Jonathan can send me any info that he has, the agenda for tomorrow, and I'll forward it along to everybody registered for the event. And I will be sending that survey shortly, most likely after the event is concluded. So if you have any feedback or anything like that, just feel free to let us know how we could do better, and anything you enjoyed or anything you'd like to see discussed. Yeah, and that's it. Last call for any other questions. We have like 5 minutes more. If there's something else, we can discuss it.
If people are still working on or don't have Python installed on the machine or PyCharm, typically that's the first hurdle. I saw some talk about that in the chat, and that obviously is a very important thing to do. Ultimately, it shouldn't be that hard of a process. If you have a MacBook, it's pretty easy. Actually, Python comes installed by default on OS X. But it can be a little trickier on Windows, or if you're using like Linux or something. I understand. I would suggest Googling around for installing Python on your particular operating system. once, just keep in mind too that installing Python is one thing, and installing an IDE such as PyCharm is another thing. And what you need to do is configure PyCharm to use Python, and PyCharm will do its best to help you set that up. Just look out for the little notifications.
Perfect. Well, thank you to everybody who made it today. I hope you guys got a lot out of it. And there's, like I said, there's plenty to do for tomorrow too. And can't wait to see everybody again tomorrow. Thanks, Jonathan, for hosting. I know you came in last minute, and we really appreciate all the material that you pulled together. And hopefully we'll have more tomorrow.
My pleasure.
Thank you, everybody. We'll
Later.
see you tomorrow.